Good morning. Today we're going to continue solving logarithmic equations. If you guys notice on these two examples that we have here on the objective met, we're going to be working with equations that have two logs on the left hand side, on the right hand side. They have two logs on one of the sides. So in order to be able to solve these equations, we're going to have to use the properties of logs that we cover on the last sections to be able to simplify before we actually solve the equation. The two properties, the product property will allow us to condense from two logs that are adding with the same base into one log. And because they're adding, the u and the v now will be multiplying. The quotient property allows us to go from two logs that are subtracting. We're going to condense it into one log with a division in between. So let's look at example number 1. On example number 1, we have log base 7 of 2x minus 3 plus log base 7 of 2. Just the same way as if we have 2x plus 3x is equal to 10, in order for us to be able to solve this equation, we want to be able to combine the like terms, so that will be 5x is equal to 10. So now we can solve it. But before we can actually do anything, the first step will be to combine like terms. Now we can solve it, x is equal to 2. In the same way, we want to be able to combine both logs. We want to be able to condense both logs. They both are base 7. So using the product property, because there's a plus in between, there's going to be multiplication now. So we're going to condense it, log base 7, and we are going to multiply. So let's go and multiply it out. 2 times 2x will be 4x. 2 times negative 3 will be negative 6. And it's equal to 1. Now I can get rid of the log base 7. The inverse of a log is a base. We're going to exponentiate base 7 on both sides. Now the log base 7 and the base 7 cancels. We have 4x minus 6 is equal to 7 to the first power. 7 to the first power is just 7, so 4x minus 6 is equal to 7. And I can solve the equation, move that 6 to the right, becomes a positive 6. Now we have 4x is equal to 13. I'm going to divide by 4. X is equal to 13 divided by 4. Will be 4 goes into 13 3 times, and I have 1 left over. So 3 and 1/4. It says for logarithmic equations, we need to check for extraneous solutions. If you guys remember, we cannot take a log of 0 or negative number. This number, we know that this one's fine because this is a 2, it's bigger or bigger than 0. We have to make sure that if we plug in the value of x in here, it is going to be greater than 0. It cannot be equal to 0 or it cannot be a negative number. So let's go and check. And yes, you must check each of your problems. Checking is a quick process. We want to make sure that 2x minus 3 has to be greater than 0. So let's go and plug in the value of x. I'm going to plug in the 13 over 4. So 2, instead of the x will be 13 over 4 minus 3 is greater than 0. Place over 1. Let's go and cross simplify first. So it gives you 13 over 2 minus 3 is greater than 0. That will give me 6 and 1/2 minus 3 is greater than 0. Is 3 and 1/2 greater than 0? Correct. You have to make sure, if you don't check and this gives you a negative number, then the answer will be incorrect. Letter B. we have an equation, we have two logs on the left hand side. So we are going to condense it into one. We're going to combine both logs into one. Since there's a minus in between, we are going to divide the x plus 2 divided by x. And that's going to be equal to 2. Now I want to get rid of the log. The inverse of a log is a base. We're going to exponentiate both sides with base 3. That will cancel. So I have x plus 2 over x is equal to 3 to the second power will be 9. Now to simplify this, I'm going to place this over 1. And now I can just cross multiply. So x plus 2 times 1 will be x plus 2. X times 9 will be 9x. I can solve this. I'm going to move my x to the right, becomes a negative x. That'll give me 2 is equal to 8x. Divide by 8 on both sides. That'll give me x is equal to, reduce will be 1/4. Now I want to make sure that I check. This, whatever's inside the log, has to be bigger than 0. So check. 1/4. So x plus 2 has to be bigger than 0. X is 1/4. So 1/4 plus 2 is greater than 0. Yes. Also, x has to be greater than 0. Is 1/4 greater than 0? Correct. So the answer is